Hello there, 8th graders. This is Mrs. Minowitz, and I am here today to talk to you about the water cycle, which is also called the hydrologic cycle, as well as moisture in the air and clouds. The first thing that I would like for you to do is to go ahead and flip your sheet over so that you can find the diagram of the water cycle. And I would like for you to try to fill it in based on what you already know about the water cycle. There's a word bank on the front. So I would like for you to go ahead, pause the video, try to fill it out, and then come on back and we'll go through the answers here. So hopefully you've had a chance to go ahead and take a look at that. Right now we're going to go through it and talk about the different parts of the water cycle, which hopefully is already familiar to you. We're going to start in the bottom right-hand corner with our body of water here. This could be a lake, it could be a river, it could be the ocean. We'll just put a lake because we're in Minnesota and we have lots of lakes. The first process that is shown here by the arrows that are moving upwards is evaporation. So over time, our water, the heat from the sun, things like that are going to heat up some of that water. It is going to evaporate. It is going to go from a liquid to a gas. Okay, and that enters the atmosphere, and we have water vapor in our atmosphere. Over time, as that rises up in the atmosphere, it is going to start to cool. And when it cools, it is going to condense. And our process here then is condensation. Okay, where it goes from a gas back to a liquid. And that is how our clouds are formed. And our clouds are, again, tiny little droplets of water. They are not a gas. They're actually liquid particles up there in the atmosphere. We're going to leave this side of the diagram here because we're going to take a look at what's happening on the left-hand side here. So on the left, we have some similar processes that are happening, except if you look here at the bottom left, it says this is trees. Now, this could be any type of vegetation. It could be some bushes, other living things. It does not just have to be trees. But those hold a lot of moisture. And over time, they're going to lose that moisture through this process called transpiration. Now, this is very similar to evaporation. We're going from a liquid to a gas. The main difference here, though, is just that we're starting with a plant, and that is our water source here. Okay, so transpiration involves some sort of vegetation where we have that liquid water being turned into a gas. And again, that transpirated water in the atmosphere is going to, over time, rise and it will cool, and then some of it will condense, and we get condensation forming our clouds again. Now you see here as our clouds build and we start to get more water molecules, over time we're going to see some precipitation. Examples of precipitation are rain, snow, sleet, freezing rain. We'll talk about hail in a little bit here. Okay, those are all examples of precipitation. Now, as that moisture falls to the surface, we are going to have some of that run off into lakes, rivers, and streams. That's called surface runoff on the surface. This water also can soak into the ground, and over time it will eventually run off again into our lakes, rivers, and streams, but since it's been underground, it's called underground runoff. And then our final blank here is our collection or accumulation of this water back into a body of water such as a lake. The entire process that is driving our water cycle is this heating that we get from the sun that starts our evaporation, and then the cooling that leads to some of the other processes like condensation. So heating and cooling is what is driving our water cycle here. Okay, we're going to shift gears now, and we're going to talk about moisture in the air. So evaporation, like we talked about in the diagram, is just the change in the state of matter from a liquid to a gas. Condensation, then, on the other hand, is the change in state of matter from a gas back to a liquid, and this usually happens when we have something cooling, like when we have air that hits a cold surface, like a cold can of pop in the summer, and then that turns water vapor in the air back into a liquid because it has cooled. This is also what helps to explain how our clouds are formed. Both of these processes are involved. Okay. Moisture in the air. Temperature determines how much water vapor can be in the air. So depending on the temperature, you can have more or less water vapor in the air, because if it's really, really cold, our air molecules are very, very close together, because they're condensed. That makes it much harder for water vapor to form in the air. This explains why it is dry in the winter, okay, and humid in the summer. When it is warmer, the air molecules are further spread apart, so they're moving around. It is much easier for water vapor to form in the atmosphere or in the air around us. So this explains why it is dry in winter and humid in the summer. In Minnesota, we get so cold. The air is very dense that it's hard for that water vapor to form. Humidity, which I'm sure you're all familiar with living in Minnesota, is just the amount of water vapor in the air. So when we're talking about it being very humid, we're saying that there's lots of water vapor in the air. This often feels kind of sticky. A lot of people think it feels pretty gross when it gets very humid. When there's little humidity, there's very little water vapor in the air. All right, shifting gears now to clouds. Clouds are a collection of millions of tiny water droplets or ice crystals. You can actually have clouds that are made out of solid ice crystals if you get them far enough up in the atmosphere. So how clouds are formed? We have water vapor in the air that is caused by evaporation from a liquid source. So we have gas, water vapor in the air. When that warm air rises, it's going to cool. And when it cools, it will condense. And in order for clouds to form, they have to condense on what are called condensation nuclei. And when that happens, you actually get our cloud to form. So water evaporates, it's water vapor in the atmosphere. It rises, it cools. When it cools, it condenses on condensation nuclei. Now, what are condensation nuclei? Condensation nuclei are tiny particles in the atmosphere from natural events or human events. These are things like dust, ash, fertilizers, salts, aerosols, all sorts of tiny little different particles that already exist in the atmosphere. These are what water vapor condenses on, and when that happens, that helps us to form our clouds. If we did not have condensation nuclei, it would be very hard for our clouds to form, because it would be much harder for the process of condensation to happen. So to kind of put it into reference here with size, the average raindrop size is about 2 millimeters. The average cloud droplet size is about 0.02 millimeters. And the average condensation nucleus size, those are the particles, dust, stuff like that in the atmosphere, is 0.0002 millimeters. So much, much smaller. But that kind of puts it into perspective. There are 3 main different types of clouds that we're going to talk about, and then we're also going to look at some examples of some special types of clouds. So cirrus clouds, these are ice clouds. These ones are 3 or more miles up in altitude, and this is where temperature is below freezing even in summer, so they're always ice. Cirrus clouds look like this. They're kind of thin and wispy. They're usually very high up in the sky because they need to stay cold to be constantly made of ice. These are cirrus clouds. Cumulus clouds are the ones you probably are most familiar with, or when you think of clouds, what you probably are thinking of. These are the fluffy white cotton ball looking clouds. It's a big puffball kind of thing. Looks like this. These are cumulus clouds. When you're thinking of like shapes with clouds, this would probably be it. Stratus clouds are the third main type of clouds. These are thin white sheets that cover the entire sky. So when it's often overcast, very often, that is stratus clouds. Fogs is actually stratus clouds that are closer to the ground. So you're actually like in a cloud when you are going through fog. And this is an example of stratus clouds. We've seen these some in class. Nimbo or nimbus. If we attach the phrase nimbo or nimbus, like nimbostratus or cumulonimbus, if we attach that prefix or suffix to a cloud name, it means that precipitation might fall. So if it's raining, we probably have nimbostratus or cumulonimbus clouds that are out in the sky. There are some special clouds we're going to take a look at here really briefly just to see some different ones. These are ones called orographic clouds. They get their shape from mountains or hills. And these look like this, where it's kind of like over the mountain or hill. Kind of cool. Lenticular clouds are shaped like lenses or almonds, and they get their shape from hilly terrain or the way that the air is rising. They look kind of like this, different from some of the other clouds that you might see. Mammatus, I think these are some of the coolest looking clouds. Basically, these are clouds that have like, looks like there's pouches underneath them. They're often underneath cumulus or cumulonimbus clouds. It's a really weird phenomenon. It almost looks fake as you look at these pictures, but this can actually happen. This is called mammatus, and it looks really weird. It's like there's cotton balls at the bottom of pouches of these clouds. Here's another picture of mammatus. Nigreus clouds, these ones only occur at high polar latitudes in winter because you have to have temperatures of minus 176 degrees Fahrenheit. And these ones actually have these cool looking different colors here. Very cool clouds, but only happen at very cold temperatures. The last thing that I want to talk about here is hail. So hail is an interesting form of precipitation that we get from a cloud, because what happens is hail forms from cumulonimbus clouds when we get a strong updraft. So that's a force move pulling it upwards. So it carries raindrops and ice crystals back up into the cloud where temperatures are below freezing, and then raindrops freeze into what's called grapple or frozen raindrops. So it's carried up through the clouds where millions of supercooled water droplets collide with the ice surface and are instantly frozen. And that causes the grapple to become larger. So when it reaches the top of the cloud, it begins to fall back downward, and then the updraft pulls it up again, and we keep having this process until it becomes so big that the updraft can't keep pushing it back up, and that causes it to fall to the ground. So it depends on how large that updraft is, how large of a hailstone is going to be created, and here's some examples of some larger pieces of hail. Hope you learned something.